Suppose your organization is in a fortunate position to get a Class A address. As we said, we're not really using class-based addresses anymore, and Class A addresses are simply not available anymore, so it won't really happen. But let's suppose it. Then it means you have 24 bits to address your computers. That is 16 million numbers that you can assign to your computers. And that's just an impossible task to keep track of 16 million computers. So what many companies will do who have a biggish address would be to subnet it. What you would do is you'd split it into several different networks. Let's say you use the second byte. Remember, the first byte is given, that's a Class A address. So you'd use the second byte to indicate which department in your organization gets it. Now, by way of an example, let's suppose you are the military and you get a Class A address. Then you may perhaps say, okay, subnet number 1, which I will indicate in the second byte, is the Navy, and subnet number 2 is the Army, and subnet number 3 is the Health Services, and so on if you have more branches in your military. Now, the way in which it will work is whoever sends a message to the military will still send it to your A address, and then you will be responsible for routing it inside your organization. How we split addresses into such subnets is the topic of today's video. We're also going to talk about the opposite. If you have multiple small addresses, how can you combine them into a bigger address space? And that's known as supernetting. And finally, we'll also touch on where do you get these IP addresses from. Let's use a Class B address as an example to illustrate how subnetting works. Now, suppose that I've been given the address 172.16.0.0. That's my company's address. It, as you probably have seen, is a private address, so it's not one that would really be assigned to me, but for our purposes of illustration, that is good enough. So what I can do now is I can decide the way in which I'm going to subnet this is that I'm going to use that byte to indicate the department in my company. So I may, for example, say, okay, on subnet number 1, I'm going to put, let's call it production. And on subnet 2, I'm going to put sales. And on subnet 3, I'm going to put PR or advertising or whatever. And subnet 4, I'm going to put other departments and so on. Now, what this means is that if I want to assign an address, and this is perhaps a way of just keeping track of where my addresses are, but it may be more than that. I may, for example, decide that when I buy that first computer that I'm going to put in PR, well, that's in subnet 3, and I can't call it number 0 because 0 now in this bigger address would be the subnet address, so I have to call it 1. And then the second computer that I could buy for my PR department is 2, and so on. Now, as I've said during the introduction, is that parties outside of my company will not know that I'm using this subnetting. They will look at this, they will recognize this as a Class B address, and they will send whatever is sent to my company. If it's an email, it will be sent to my company. I, in my company, can then employ routers to say, oh, okay, this is intended for, look it up, PR, and then I route it to the PR network. It's possible that these various divisions in my company are kilometers apart. There's no reason why my sales force needs to be located where my production facility is. So it may make sense for me to route it. Or they may be close together, and it, again, for management purposes, just makes it simpler to route via these subnets. Given this choice that I've made, means that I have to specify a new net mask for internal use. And the new net mask would be 255.255. That is because this is a Class B address. That's what's been given to me. I cannot change the initial 2 bytes at all. But in my company, I'm using this department number as part of my subnet address, and I will only use the bottom byte to indicate the machine within that department. As an aside, I previously said that I would begin to talk about classless addressing. And what we have in this context that is very useful is the notion of classless interdomain routing. It's a notation CIDR. And with CIDR, rather than specifying a net mask, I simply say how many bits I will allocate to the address portion. So my PR department subnet will be 172.16.3.0. I'm talking about the subnet, that's why I have the .0. And I'm going to say that I consider the first 24 bits to be the network. In other words, the remaining 8 bits would represent the host on that network. So rather than specifying that long net mask, this is the more modern way of doing things, and it does away with the whole notion of classes, because after any address that has been properly configured, we can simply specify the number of bits that should form a part of the address. Again, in this particular example, people outside my company will not know that I'm using 24 bits for my address. This is purely inside my company, and outside they will still be using the initial 16 bits to get it to my company. And as noted, I then route it differently. Now, based on my choice that I've made here, I can have up to 256 departments in my company. It's a pretty big company that I'm running if I have 256 departments. On the other hand, I have a limited number of hosts in each department. Again, with 1 byte, I can address 256 possible machines. However, remember that 0 is reserved for the network, and 255 is reserved for broadcasting on that subnet. So it is 256 minus 2, 254 possible machines that I can address in that department. Now, if I think about something like sales, it's possible that the sales force may be using laptops and cell phones and who knows what else. They have way more than 256 devices. And as I said, I don't really need, I don't expect to have 256 departments in my company. Same with production. If it's an automated facility I'm using, I may have all sorts of industrial computers controlling various devices. And again, I may need many more than 256. So somehow I have to balance the choice that I'm making here. I made this initial choice on a byte boundary there simply because it was convenient. But I may, for example, say, rather than do an 8-8 split, I want to do, let's say, a 5-11 split. In other words, 5 bits for my department numbers and 11 bits for computers in the department. What that would mean is I can have up to 2 to the power 5, that's 2, 4, 16, 8, 16, 32 departments that I'm catering for, which, given my initial list, seems very reasonable. But in each of those departments, I can have 2 to the power 11 minus 2. So 2 to the power 11, that's 2,000 computers. And that may be a more realistic subdivision. So how do we do this? Now, on the one hand, it is pretty simple. I will write my corporate address, or the very first department in my company, maybe department number 0. Okay, I didn't use a 0 in my initial description. And their network address will be 0. So, and then I will know that my network portion consists of the 16 bits that I've been given, because, again, it's a class B address as long as we can use the word class. And for subnetting purposes, I've added 5 bits internally. So, but rather than writing 16 plus 5, I will write /21. In other words, my CIDR number that I write after the address is 21. But this brings us to a challenge. What is the number of the second, or the address of the second department, department number 2, department number 3, and so on? And let's explore that in a bit more detail. So suppose I'm indeed going to use this 511 split. In other words, I'm considering my address to consist of 21 address or network bits and then 11 host bits. What I want to work out now is how to get department 1, department 2, department 3, and so on numbered in these various subnets. The 172.16 will remain fixed. That's been given to me. There's nothing that I can do with this. What I know based on my decision is that I will split my lower bytes into a 516 portion. So in that byte, it will actually be a 511 portion. And in that lower byte, I will use 3 bits for the host. And in that field, I will use all 8 bits for the host field. So those are my host bits. That is my network bit. Let me now work out what the IP address of Department 1 Productions subnet is. Their address in binary will be 00001. In other words, I'm using 5 bits to write down the 1 that that production is. And then if I'm interested in the network address, then I know that all the remaining bits where the host will be filled in will be zeros. Network address, host portion is always zeros. So converting this back to decimal gives me, those are the 1s, the 2s, the 4s, and the 8s. So that value is 8, that value is 0. Productions subnet is therefore 172.16.8 that I'm getting from there, .0. And again, if I want to be complete, I can say that the first 21 bits are used for the address portion. Let's repeat this for department number 2, sales, and we work out what their subnet address will be. So their subnet address will work in exactly the same way. We'll do our split 5 bits for the department, and then 3 and 8, which brings us to 11 for the host. I am interested in sales right now. In binary, that would be 1, 0. Padding it to use all 5 bits means I will get that value, and then the lower order bits will all be 0, because we are talking about a network address, and converting this back to decimal, that is 1s, the 2s, the 4s, the 8s, the 16s, and that is 0. So my sales department will be 172.16.16.0, getting the 16 from there and getting that 0 from there. What we've just done was to calculate the subnet addresses of our various departments. What remains to be done is to calculate the broadcast addresses of the various departments. So if, again, we look at production, then it's the same that we had in the previous instance, where we can only work with the lower 2 bytes. And the split remains 5, and then 3 plus 8 to give us the 11 host bits. Now, if I'm talking about department 1, then just as we said previously, the subnet part, those 5 bits that form part of the network, will be number 1. But for a broadcast address, I need to put 1s in all the bit positions that remain, in all the host bit positions. So that would be 1, 1, 1, all 3 of them. That would be 1, 8 of them. To convert this number to decimal, that we already recognize as a 255. This one needs a little bit of a calculation. You can go and do the calculation. It's 1 plus 2 plus 4 plus 8. Easier way to do that same calculation would be to say if that were a 1, it would have been 1, 2, 4, 8, 16. So if it were 1, 0, 0, 0, minus 1, it would have given us all 1s. If you follow that, great. Else, you can do the calculation the long way. Short answer is that the value that we are looking at there is 15. So the broadcast address for production would be 172.16. And getting the 15 from there and the 255 from there. Let's now look at the broadcast address of the sales department. It's the same subdivision of the lower 2 bytes that we had previously. Again, given that sales is department 2, we will write 2 in binary and then pad the 5 bits that we're using for the network portion with zeros. And in this case, we are calculating the broadcast address. So the host portion needs to be all 1s. And again, to calculate or convert that to decimal is very easy, 255. This one is also possible to do very easy, very simply. But if we want to do it the long way, there's a 1, there's a 2, there's a 4, there's no 8, but there is a 16. So 16 and 4 is 23, which means that is 23, and the broadcast address for sales would therefore be 172.16.23, getting that from there, .255, which we get from there. IP version 4 has 2 main problems. The one problem is that the addresses are becoming very, very scarce. The other problem is that the Class C addresses are really too small to be useful for many companies nowadays. And what we may want to do is to combine these smaller addresses into bigger address spaces. In other words, where with an IP, with a class C address, where you can only address 254 computers, we may want to make that a little bit bigger, and perhaps we can do that by combining two class C addresses, and that is known as supernetting. So let's look at an example of that. Again, I'm going to use a private address, which makes it a bit unrealistic, but it's fine for the purposes of illustration. So suppose I have the address 192.168.10.0 and 192.168.11.0. The question now is, can I combine those two into a bigger entity? Part of that answer is definitely no, I can't. Because as far as the world out there is concerned, these are class C addresses, and when I combine them, they will still see them as the same address. So no, I can't do that. But maybe the world out there, whoever that is, and we'll look at that in a moment or two, can indeed combine them. Let's see if it's possible. So to combine them, what I want to do is I want to not use those 24 bits as the address, as the network address. I want to use only 23 of them. So the 192.168 will remain as is, but I need to play with that 10 and that 11 to see whether I can combine them into one single address. Now, let's write 10 in binary and 11 in binary. So 10 in binary is 1010. Actually, this should be in 8 bits because I'm talking about a whole byte. So there's a 0000 added in front. I'm not really going to use those. And 11 is 1011. And again, going to pad it up to make it a full byte, and I'm not going to worry about that. And what I see in this example is that I'm fortunate that the portions of the address that I want to use that should remain the same are indeed the same, and the portion that I now want to use for hosting purposes gives me all the possible combinations that I can wish for. With 1 bit, I can only hope for a 0 and a 1. If I wanted to add 2 bits, I would have needed 0, 0, 0, 1, 1, 0, and 1, 1. For 3 bits, all 8 possible combinations, and so on. So in this example, it at the very least seems possible to do. So what I can do now is to say that I want to use 192.168 dot, and then I have to convert this number that I'm seeing here, which is 0.000.101. I have to convert that to decimal, but before converting it, I need to pad it out with zeros. The entire host portion needs to be padded out with zeros. I've got 7 bits there, so I need to add a 0 to complete the entry. By pure luck, it happens to be the one that I started out with, so I don't have to think about it a lot. It is 10, and then the lower portion will remain the host portion, and therefore I can say that it will remain 0, and I can now say that I'm going to use not the 24 bits that I would originally have used for a Class C address, but 23. To calculate the broadcast address of this, I would again use the 192.168. That was given. And I now in binary have to write down the network portion, which was 101, that part that you see there. And I have to pad it with ones. Remember, all the host bits have to become ones. Again, I'm fortunate here to convert it back because it's the other number that I started out with, so it happens to be 11. It won't always be this easy, especially if you are combining more than two of these addresses. It won't be as easy. But then the bottom byte, the lowest byte, will be all ones because I'm talking about broadcast, and that would be 255. So there is my broadcast address on the SuperNet. As I noted earlier, this the world needs to know about. So in general, this is not something that I can do on my own. Whatever authority gives me this address or these addresses will have to combine them. And let's now look at that. Who do I get an address from if I want an IP address? And at the same time, who is able to do subnetting and supernetting on a level where the world will know about it? Let's now ask the question, where do I get an address from? In the early days, many years ago, you would simply have asked a person with the name John Pastel, and he would have handled that. But that's in the very early days. Over time, a committee was established, and that is the Internet Committee on Assigned Names and Numbers. And they were responsible for handing out IP addresses. In fact, the IHANA subcommittee was eventually tasked with that. But this clearly is not quite in line with the spirit of the Internet, where everything is delegated down as far as possible. So at some stage, not that many years ago, the notion of regional Internet registries was established. And they are responsible to deal with IP addresses within their region. So to start with one that is of importance for us, Afrinic was established as one of these regional Internet registrars that, as you can see, clearly is intended for African, also for the Indian Ocean Islands, and the NIC is Network Information Center. For Asia and the Pacific, APNIC was established, so the Asia Pacific Network Information Center. For Latin America and the Caribbean, LACNIC was established. For North America, the name doesn't quite follow this pattern. It is the American Registry for Internet Numbers. And then Europe doing their own thing and picking a name in French that I'm not going to try and pronounce, but that has the acronym RIPE. To get to any of the websites of these organizations, they all use a .NET, upper level, top level domain. So in principle, if you're based in Africa or in the Indian Ocean Islands, you would go to Afrinic and ask them for an address. In practice, you will probably go to your ISP, and the ISP will talk to them, so you can't directly talk to them. However, one of the interesting things that we can do with all of these information centers, with all of these regional registries, is to try and determine whom an address belongs to. So who is the owner of a given IP address? Let's do that. Here we are on Afrinic's website. As you may recall, am using a private IP address on my internal network, 10. whatever. But the moment that my requests go out to the web, they get assigned an IP address that is supplied by the ISP. And I now want to find out who that ISP is. Going to the top, zooming in on this top right-hand corner of the website, you will see that there is a who is field. And if I select that, I get a query form that I can complete, a lookup field. Now, while we are here, you may see that there is quite a couple of things that I can look up. There are things about AS, this and AS that. You may recall in the very first video about the network layer, we spoke about autonomous systems. So you can see that we can look that up as well here, but that's not our purpose right now. What I rather want to do now is to search for the address that belongs to me right now. And that happens to be 169.1.115.102. So this is the address that's been assigned by the ISP to me. They will assign this address tomorrow to someone else, and then the day after that to someone else again. It does not belong to me in any way. It doesn't point to me, except right now while I'm busy recording this or for the rest of today. Having entered that, I can now click on search. Perhaps before I do that, you may have noticed, or you may have done the calculation, you may know that 169 means this would have been a class B address if class-based notation were used. So clicking on search, what we get as a result is that the address that was assigned to me sits in a range that stretches from 169.1.64.0 right up to 169.1.127.255. If you look at this range, you should notice that this is not the entire B range that we would have expected from a class B address. Class B address would probably have gone from, in the lower 2 bytes, .0.0 up to .255.255. This is not the case here. So this is a subnet of what would have been a class B address. To work out what the subnet is, you can write down the host portions of these two addresses, and you will see that in the third byte, they both start, the upper and the lower end, start with a 0-1, and then they differ in the remaining bits. So what this means is we've extended the network part of the address by 2 bits. So the entire network part consists of the initial 16 bits that we would have expected for the class B, plus 2 additional bits. So the full network address that we are using here, which is a subnet, the full address would be 169.1.64.0/18. You can also see that this particular address belongs to AfriHost. The net name is something that is chosen by the entity that applies for the block from Afrinic. So the fact that it is called AfriHost-dynamic means that it sounds as if used for dynamic addresses, DHCP addresses. That's something that we can infer, but we cannot rely on that. I am still on the Afrinic site. I've just quickly reconfigured my router, and now the address that's been assigned to me happens to be 197.185.110.3. What you can see on this screen is that the block that I am using is 197.185.0.0 to 197.185.255.255. Now, being a Class C address, that third byte should not have changed. It should have remained the same, because for a Class C address, only the bottom value is used for host numbers. So this is an example of supernetting that has occurred. You can see that this one happens to belong to RAIN, and it does not take a lot of thinking to see that the address that we are talking about here, the network address really, is 197.185.0.0/16. 256 Class C addresses have been combined here to form a new Class B-like address. In order to understand how these addresses are assigned and how they work in practice, you should look up the IP addresses of a number of entities. You may look at the IP addresses that you get from your ISP, like I've just done, but you can also look at the IP addresses of a number of very well-known companies, Google, Microsoft, and so on. You just use NSLOOKUP to determine what their IP addresses are, and then you can go to these various regional Internet registries and look at the blocks that have been assigned to them for that use. Obviously, a specific entity may have multiple blocks assigned, so it's not the entire block that you will see. Do that so that you can get some feeling for how these values are allocated, but also do that to see what happens when you, for example, have a company that is located in the United States and you look it up on Afrinic. How do you determine where to start? Does Afrinic point you to ARIN? Do that, play with it. That's the way to learn. See you in the next video.
Music